at gradient. Gradient is a measure of how slopey something is. So that is more slopey than that, so that has a higher gradient than that. And the mathematical way you describe that is you say, well, how far up does it go for every one along? And the way you work that out is the change in the vertical divided by the change in the horizontal. Now, vertical and horizontal mean that they're at right angles to each other. So horizontal is along the way, it's like along the horizon. Vertical is up and down the way. So, gradient is the change in vertical over the change in horizontal. So, here we have an example. We've got a height and we've got a horizontal distance. And height, by definition, is at right angles to the horizontal distance. So we've got our right angle triangle there. And we can work out our gradient. There's a trick in the question you need to watch out for. They've given you the height in centimetres, it's 25 centimetres, but they've given you the horizontal distance in metres. Now, gradient has no units, but both measurements that you use for it have to be in the same units. So we're going to have to do something with that. So let's change the 4 metres into centimetres. So 4 metres, and if you're going to put into centimetres, well, you know that there must be the number 100 in there. And centi means 100. It's something to do with 100. And you're expecting there to be a lot more centimetres in there than there are metres. So it's going to be multiplying. So it's 100 times 4 equals 400 centimetres. So there we go. We've got our ramp now. It's 25 centimetres up and 400 centimetres along. So the vertical is 25 centimetres, the horizontal is 400 centimetres. So the gradient equals the change in vertical over the change in horizontal equals 25 over 400. Right. But we're trying to say, is this greater or less than the maximum 1 over 14? So you need to be able to compare that with 1 over 14, which you're not going to be able to do as it stands terribly easily. I think what we want to do is simplify this. So you know how to simplify fractions, you just have to divide the top and the bottom by the same thing. Well, I am sure that both of these will divide by 5, so that's what I'm going to do. So you can get 5 5s out of 25, you can get 5 8s out of 40, so you can get 5 80s out of 40. Now both of those will also divide by 5, so I'm going to do it again. Divide by 5, divide by 5. And, well, you can get 1 5 out of 5. If you can get 5 8s out of 40, you can get 16 5s out of 80. So that's 1 over 16. You can do this in as many steps as you want. You might well have been able to do it straight from here by dividing by 25, because there are 4 25s and 100, so there's going to be 16 25s and 400. At any rate, we know that our gradient for our ramp is 1 over 16. The maximum we're allowed is 1 over 14, so does it pass? I'm dividing something into 16 pieces. Those pieces are going to be smaller than if I'm dividing it into 14 pieces. So 1/16 has to be smaller than 1/14. So 1/16 is less than 1/14. So it's less than the maximum, so yes, the ramp does pass. So, we've got 3 steps to this calculation. We've got to convert the units to be the same thing. You always have to watch out for that. You've got to actually do the gradient calculation, and that formula is in your exam paper. And then you've got to do the comparison at the end. So, well, this time we've got everything's in meters. We do have 3 distances, and there's a reason for that. Okay, we want a right angled triangle, and whatever else this is, it's not a triangle. It's also very definitely not to scale. But what we want to do is we want to extract a triangle from this. So we're going to chop this across here so that what we've got here is a triangle, a right angled triangle. So let's take the triangle out. Also not to scale, not to that scale or any other scale. Right, if that was 17 meters all the way down, and this is 2 meters, then this bit must be 17 minus 2, which is 15 meters. And along the way we have 200 meters. Okay, so we've sorted out the awkward bit. Now we want to find the gradient. Gradient equals vertical, change in vertical over change in horizontal. Well, that's fine. This is the change in vertical. This is the change in horizontal. Always a good idea to actually mark that on. So we've got 15 over 200, which is a fraction which we could simplify. So we can simplify that fraction nicely. There are 3 5s in 15, there are 45s in 200, but actually I think I would almost be more inclined to say, well, 15 divided by 2 would equal 7.5. So 15 divided by 20 would equal 0.75. It's going to be one place lower. 15 divided by 200 will be 0.075. So that's probably how I would be inclined to do it. Whatever. The answer is 0.075. So if you look at that, you've got 0.06, you've got 0.075, you've got 0.08. So this is 600ths, this is 700ths, plus another 5 thousandths. This is 800ths. So that is falling between those two. So yes, the zip line. Well, yes, the zip line passes as the gradient 0.075 is greater than 0.06 but less than 0.08. Okay, and finally, where you're trying to find the gradient, so you need to know the change in vertical and you need to know the change in horizontal. There's the vertical, there's the horizontal. Unfortunately, you know nothing about the horizontal. You know the diagonal, the hypotenuse, but you know nothing about the horizontal. And the vertical, they haven't given you the change, they've just given you the starting height and the finishing height. So, first of all, we have to work out what the change in vertical is. So that's 132 minus 129 equals 3. So that's 3 meters. Now, we don't have the horizontal, but we've got the hypotenuse. So we can do Pythagoras. We can work it out. Here we go. There's C, there's B, there's A, and C is 5, B is 3, A, well, we don't know yet. C squared equals A squared plus B squared. 5 squared equals A squared plus 3 squared. 25 equals a squared plus 9, which means that a squared is going to be 25 take away 9. Now, you might have written it down as a squared equals c squared minus b squared, which will get you exactly to this point. That's fine if that's what you did. Just remember that if you're going for a shorter side, you're always going to take away at some point, and that the hypotenuse will come first in the sum. Okay, so equals 16. So if a squared equals 16, you have to ask yourself, what times by itself gives me 16, which fortunately is a nice neat number, it's 4. So there we go. We now know that our horizontal is 4 meters. So now we can do gradient equals change in vertical over change in horizontal equals 3 over 4. And we can turn that easily into a decimal if we want, because we know that 3/4 is 0.75. But if I'm not comparing it with a decimal, I'm quite happy with it left as a simplified fraction.